Hello everyone! So today, we are going to talk about Nature's Numbers by Ian Stewart, specifically its first chapter. So for today's video, it's actually going to be a collab between Kate, Vinnie, and yours truly. Now let's get started. No two snowflakes are ever exactly the same, but they all have six-fold symmetry. 400 years ago, the German astronomer named Johannes Kepler wrote a small book named The Six-Cornered Snowflake. In it, he argued that snowflakes must be made by packing tiny identical units together. This was long before the theory that matter is made of atoms had become generally accepted. Kepler performed no experiments. He just thought very hard about various bits and pieces of common knowledge. His main evidence was the six-fold symmetry of snowflakes, which is a natural consequence of regular packing. If you place a large number of identical coins on a table and try to pack them as closely as possible, then you get a honeycomb arrangement, in which every coin, except those at the edges, is surrounded by six others, arranged in a perfect hexagon.
So the next topic we're going to be tackling is about patterns and numerology. What are patterns?
Patterns possess utility as well as beauty. Once we've learned to recognize a background pattern, exceptions suddenly stand out. The simplest of nature's patterns are numerical, and we use numerology to explain it. Numerology is the easiest method for finding pattern and consequently the most dangerous because anybody can do it. Patterns are clues to phase transition. To further elaborate it, let me tackle fractals and chaos. Fractals and chaos are described in the nonlinear systems theory. Chaos from the word itself is chaotic and unpredictable or apparent randomness. It deals with phenomena that is effectively impossible to predict or control and are described through fractals or the picture of nature. Fractals are geometric shapes and or waves that repeat structure on even finer scales and provide order. Example of shapes associated with fractals are circles found in rainbow, whirlpools, and tiny vortices. Its example also extends to stripes and spots of animals in the proportion of the human body. Since fractals are described through scales and pictures, we can now associate it with symmetry. Symmetry is an object or process that is invariant to a transformation. To visualize chaos and fractals, the symmetry in an object is broken down with respect to scale. Scale can change, but structure will repeat itself over various levels of magnitude, as stated by Newton.
Hello, I'm Vinnie, and in this chapter I'm going to tell you what exactly is mathematics is to nature as Sherlock Holmes is to evidence. As we all know, there is much beauty in nature's clues, and we can all recognize it without any mathematical training. There is beauty too in the mathematical stories that start from the clues and deduce from the rules and regularities, but it is a different type of beauty, applying ideas other than things. Here's what it is about mathematics is to nature as Sherlock Holmes is to evidence. If the great fictional detective is given a cigar butt, he could deduce the age, profession, and the financial position of its owner. His partner, Dr. Watson, who was not as sensitive to such matters, could only look in baffled admiration until the master revealed his chain of impeccable logic, when presented with the evidence of a hexagonal snowflake, whereas proven that mathematicians can deduce the atomic geometry of ice crystal. If you are a Watson, it is just as baffling a trick, but I want to show you what it's like if you're Sherlock Holmes. Patterns possess utility as well as beauty. Once you have learned to recognize a background pattern, exceptions suddenly stand out. The desert stands still, but the lion moves. Against the circling background of stars, a small number of stars that move quite differently beg to be singled out for special attention. The Greeks called them planets, meaning wanderer, a term retained in our word planet. It took longer to understand the patterns of planetary motion than it did to work out why stars seem to move in nightly circles. One difficulty is that we are inside the solar system, moving along with it, and things that look simple from outside often look much more complicated inside. The planets were clues to the rules behind gravity and motion. We are still learning to recognize new kinds of patterns. Nature knew about these patterns billions of years ago, for clouds are fractal and weather is chaotic. It took a little while for humanity to catch up and distinguish these kinds of mathematical discoveries. Just like how Holmes investigates his cases, that kind of action also exists in the world of mathematics, and we are able to continue and learn new and great things, for we are living in a world surrounded by mathematics. And in our everyday lives, we get to investigate everything about mathematics. It is not just in this discussion that you will feel like you're home, because as you get to see a side of nature, you will be able to find evidences of how mathematics dwells in every corner of the planet.